बाकी लोग ने सॉरी
क्या क्या बोल रहे हो?
बोलो, बाकी लोग ने ये नहीं किया था क्या उसमें, ये एनरोलमेंट नहीं किया था क्या बाकी लोग?
So, in the last few sessions, we have completely discussed what is a switch, how switch forwards, how switch forwards data. This is what we had learned. And using VLANs also, how does it forward the data? This is what we have already learned now. Okay. So in today's class, what we are going to learn is a new topic which is called as spanning tree protocol. And spanning tree protocol, uh, we will learn what is spanning tree protocol, why or what was the need to bring a protocol like that. Okay. So the first thing that we're going to deal is we are going to deal uh, uh, a scenario before spanning tree protocol. Scenario before spanning tree protocol was created. Okay. So if we understand what was the scenario before spanning tree was created, we would understand why spanning tree protocol exists. And with that, we will understand uh, what is the help, okay, or what does spanning tree protocol solve. Okay, this is what we will learn after today's class. Right. So now, before the spanning tree protocol era, right? So let's imagine there are multiple switches, or let's just imagine there are three switches. Okay. I will use only three switch example to explain the scenario before spanning tree protocol, right? And probably I will use only three switches to explain the whole spanning tree concept itself. Now, imagine as I said, there are three switches: switch one, switch two, and switch three. Okay. These three switches are interconnected to each other, and every switch is connected to a PC. Right. Again, we will assume the same scenario where the PCs know about each other's MAC addresses, but the MAC address table of the switch is empty. These are the two assumptions that we will consider. So this is switch number one's MAC address table. Okay, I'm using only MAC column and interface column on all the three switches. I'm not involving any VLANs as of now. Okay, MAC and interface. Switch number one, two, and three. So let's assume that this is interface number one, interface number two, interface number three, interface number one, interface number two, interface number three, interface number one, interface number two, and interface. Okay. So the MAC addresses of all the PCs are 111, 222, 333, etc. Now let's imagine that PC1 is trying to send PC1 is trying to send data to PC number 3. So PC1 hits the switch number 1. It makes an entry for it. 1111 was received on interface number 1. Right. It does not find the destination MAC address in the MAC address table. So the switch is going to broadcast this packet. Correct. Now let's go on the clockwise direction. So this switch receives the broadcasted packet from switch number 1. It says, or and it makes an entry for 1111 was received on interface number 3. Then it does not see the destination MAC address. So what this switch 2 does, it will broadcast this packet again. Okay. Now let's come back to our packet coming from switch number 1. Switch number 1 has forwarded this to switch number 3. So switch number 3 makes an entry for it. 1111 was received on interface number 3, and it does not find the destination MAC address. So it will also forward the packet. Let me change the color for clockwise and anti-clockwise direction. Let me use red color for anti-clockwise. So it will broadcast this packet. it will also broadcast this. Now, on switch number three, this packet that came from switch number 2 is received by switch number 3. Okay, so switch number 3 now sees that, okay, I have received a packet, the same packet with the same source MAC address, but now I'm receiving it on interface number 2. So that means this is a new update. This is a new packet. This is a new update. I will have to remove my existing entry on the MAC address table, and I will have to update it with the new entry. Done. Okay. Then in the anti-clockwise direction, switch 2 receives the packet. Okay. Switch 2 also receives the packet in the same manner, where it says that, okay, I have received the same data, but on a different interface. That means it's an updated version, or it's an updated packet, or it's a new packet. So 1111 is now received on interface number 2. Now, this particular switch number 3, will also broadcast this back to switch number 1. This packet that is received by switch number 2 in the anti-clockwise direction, switch number 2 is also going to broadcast this packet. Now on switch number 1 over here, in an anti-clockwise direction, the data is received now on interface number 3. But then seconds later, the data is now received on interface number 2. Okay, and this thing, and every time the data is received, and when the switch does not see the destination MAC address in the MAC address table, it is going to simply broadcast. Now, what will happen? When the switch 1 broadcasts this packet again, on switch number 3, this gets updated. 1111 is now received on 3. Again, this packet that is received by switch number 1 gets broadcasted back to switch number 2. Again, the packet gets updated. Then switch number 3 will broadcast. Switch number 2's MAC address will again change. 1111 is now received on 2. Similarly, this packet hits back switch number 3. Again, 1111 is now received on interface number 2. Here also, this will keep on changing. 1111 is now received on interface number 3. 1111 is now received on interface number 2. So every time in the clockwise direction and in the anti-clockwise direction, whenever the data hits the switch keeps on updating the MAC address table. Okay, so the first thing, MAC, we just saw MAC table is unstable. MAC table is unstable. That's the first thing. Second thing, we can see one single copy of the data is duplicated and it is broadcasted out of every switch. Okay, so it's like basically a chain reaction. Let me show you how that is a chain reaction. So switch number 1 broadcast this packet. This is one packet. Okay, and this is one packet. So one packet is divided into 2. Correct? This one packet is divided into 2. Switch 3 will again broadcast this packet. So switch number 3's broadcast is now divided into 2 parts. Similarly, switch number 2's broadcast is divided into 2. Then this broadcast from switch number 3 reaches switch number 2. Okay, then it will broadcast. Switch number 3's broadcast or switch number 2's broadcast will reach switch number 3. This will again broadcast. And this will go to 1, broadcast. This will go to 1, broadcast. So you see how a single packet is being in it's like a chain reaction, and it is broadcasting to every switch. And every time the switch receives a new packet, it needs to process it. Every time the switch receives a packet, it needs to process it. It cannot say it's already a duplicate packet, I am going to ignore it. No, it is going to process it. So first, the second thing that we have noticed is duplicate multiple data. Multiple data we can see in the network. Okay. Third, switch needs to process every data. Switch needs to process every data. Okay. Then processing every data, processing will slow down switching, slow down the switching parameter or the switching of data. Okay, first of all, what does a switch mean? Switch means to switch traffic from egress interface to ingress interface to egress interface. Switching means to switch the data from ingress interface to the egress interface. That's what switching means. So every time the switch receives a new packet, it needs to process. And it's just not one single packet. There are multiple packets being received on two different interfaces. The switch needs to process every single data one by one, which will decrease the processing of the switch. Okay, or processing of the switch will slow down, which is what I've written. Processing will slow down. Okay, then if processing slow down, that means there is a CPU spike. There is a CPU spike. The CPU or the memory usage of every switch will increase. Okay, memory spike of or CPU spike of every switch will increase. So this is what happens when you have multiple switches connected together and the data is continuously being looped in the network. And this is what you call as layer 2 loop. A layer 2 loop where the data is continuously moving around the switches without reaching the destination. Without ever reaching the destination, it is keep on moving. Now you may ask that why doesn't the data reach when PC number 3 responds, it should reach PC number 1, right? This data is broadcasted. When PC number 3 responds, right, it will be again sent to PC number 1. It should reach PC number 1, right? It should not be looping around. It will loop around. The reason is, okay, let me explain my question once again. My question is that you may think PC number 1 sends the data to switch number 1. Switch number 1 is going to broadcast. Okay. This broadcast packet reaches switch number 3. Switch number 3 is also going to broadcast. PC number 3 receives it. Now PC number 3 is going to respond to PC number 1, right? But when PC number 3 responds, it is going to be a unicast because in switch number 3's MAC address table, it already has an entry for this. It already had this entry. This was the first entry, correct? So based on this entry, it will send the data over here, right? Got my point? Is this flow okay? Now the problem is by the time this data reaches switch number 1, the broadcast packet that switch 3 had sent, it has already reached switch number 3 and it has updated the MAC address table. Previously, the MAC address table of switch number 1 was like this. Okay, but by the time this entry came to switch number 1, this entry was no more present on the switch. It was updated like it is now on interface number 2. What happens? Switch number 1 receives it, it will forward it to switch number 2. So it never reaches PC number 1. And that is why the data is being looped between these 3 switches and never ever reaching the destination. And when the switch loops and it never reaches the destination, you can see These are the problem that you see in the network. That is, MAC table of every switch is unstable. You will see duplicate data. Switching needs every switch, because every switch needs to process every single data. The processing of the switch will slow down and the memory will increase. The RAM usage, the CPU will spike. And this is what you call it as layer 2 loop. And this happens because of a layer 2 loop. Okay. Now, in an interview, from an interview perspective, they will ask you, what is a broadcast storm? Can you explain what is a layer 2 loop and what is a broadcast storm? Broadcast storm. What is a broadcast storm? This is what they ask. Can you explain what is a layer 2 loop and what is a broadcast? This, where the switch's MAC table is unstable. In the switch network, there are duplicate entries of the same data. The processing of the switch slows down because it has to process every single data, and the CPU spike. All this thing is called as broadcast storm. Broadcast storm. And why does it happen? It happens because of a layer 2 loop. It happens because of a layer 2 loop. Now, if I ask you to tell me what is a layer 2 loop, how are you going to explain it to me in one or two sentences? How are you going to explain it to me? What is a layer 2 loop? First, you tell me the answer, then I will let you know a better answer for to explain what a layer 2 loop is. First, tell me how are you going to explain it to an interviewer or to someone. Let's say you are explaining it to your friend, or you're explaining it to your manager or to your colleague. How are you going to explain him a layer 2 loop in one or two sentences? I'm not asking about broadcast storm. I'm asking about layer 2 loop. How are you going to explain it to him? What is a layer 2 loop?
लक्ष्य भाई, मैं क्या बोल रहा हूँ, ये एवरीथिंग लाइक मुझे सब समझ में आया,
Hmm.
लेकिन ये लेयर टू वाला स्विचेस के ऊपर है, तो इसीलिए ये लेयर टू लूप है। मेरे को
Hmm.
लूपिंग का ही मेरे को समझ में नहीं आया, सिंपली मेरे को समझाओ ना। वन टू थ्री का तो ये तो कम्युनिकेशन हो जाना चाहिए, मतलब ये डेटा वो टू लूप थ्री क्यों क्रिएट कर रहा है, ये समझ में नहीं आ रहा है मेरे को।
ठीक
और ये 5 पॉइंट आपका समझ में आया मेरे को पूरा।
ठीक है, मैं फिर से समझा अब। अब मैं हिंदी में समझा। अब मैंने जैसे बताया कि पीसी वन ने डेटा भेजा पीसी 3 को। ठीक है, ये स्विच वन पे आया। स्विच वन ने क्या किया, सोर्स मैक एड्रेस की एंट्री बनाई 1111। कौन से इंटरफेस पे रिसीव हुआ, 3 पे। अब उसने देखा डेस्टिनेशन मैक उसके मैक एड्रेस टेबल में नहीं है, तो क्या करेगा, ब्रॉडकास्ट करेगा। ठीक है, अब ये ब्रॉडकास्ट पैकेज जो है स्विच नंबर 3 पे आया। स्विच नंबर 3 ने इसकी एंट्री बनाई 1111 जो है वो उसके इंटरफेस नंबर 2 पे आया। उसको भी डेस्टिनेशन मैक दिखी नहीं, तो उसने क्या किया, ब्रॉडकास्ट किया। ठीक है, अब यहाँ पे ये वाला पैकेट जो है स्विच नंबर 2 पे हिट हो चुका है। तो स्विच नंबर 2 ने एंट्री बने 1111, कौन से इंटरफेस पे हिट हुआ है, 1 पे।
वन।
ठीक है, फिर उसको भी डेस्टिनेशन मैक दिखा नहीं, तो उसने भी ब्रॉडकास्ट किया। अब ये वाला पैकेट स्विच नंबर 2 पे हिट करता है। स्विच नंबर 2 देखता है कि भाई मेरे पास सेम कॉपी आई है, बट अब दूसरे इंटरफेस पे हिट हुआ है, मतलब ये इंटरफेस, ये वाला अपडेट जो मेरा पुराना हो चुका है, तो 1111 को अब उसने अपडेट किया 3 पे। ठीक है, ये डेटा आया स्विच नंबर 3 पे। ठीक है, और अब देखो स्विच नंबर 2 को फिर से उसको डेस्टिनेशन मैक नहीं पता, तो वो फिर से ब्रॉडकास्ट करे, उसको उसने यहाँ पे वापस ब्रॉडकास्ट किया। ठीक है, यहाँ पे जैसे ही ब्रॉडकास्ट किया तो स्विच नंबर का पुराना एंट्री जो है ये यहाँ से डिलीट हो जाएगा, और वो अब दिखाएगा इंटरफेस नंबर 1। ये था एक्चुअल एंट्री, बट अब वो अपडेट हो चुका है 1 से। ठीक है,
तो
अब
इसमें टू का रिक्वेस्ट आएगा जल्दी उसके पास कि थ्री का रिक्वेस्ट आएगा, ये क्वेश्चन है। क्योंकि थ्री भी
देखो,
तो है ना, थ्री थ्री भी तो जल्दी
हाँ,
भेज सकते हैं ना उसको, ब्रॉडकास्ट वाला
भेज
रिक्वेस्ट।
सकता है, बिल्कुल सही बोल रहे हो, भेज सकता है, पर व्हाट हैपेंस इज, अपना नेटवर्क, आजकल का नेटवर्क जो है इज सो फास्ट, is so fast, the data gets sent very quickly. You won't believe how quickly the data is being sent across the world. Okay, I am sitting on my laptop. The Facebook server is, let's say, on US, and if I do facebook.com, you can see in 2 seconds my page loads up and it shows me the Facebook's page, right?
यस
And
यस।
you won't believe how many, what are the different kind of flows. First, my data needs to go to my gateway router. It needs to find out Facebook's IP address. It will fetch Facebook's IP address. Then it will, based on the that, it will send the data to my gateway router. Gateway router, based on the IP address, it will check its routing table. Then it will send it to the nearest router. Like that, it keeps on going, and it reaches US, like in 2 seconds, and it sends back the data. So imagine the speed at which the data is being sent. Similarly, over here, what happens is this particular data, this particular data, by the time this flow, ये फ्लो पीसी वन तक या फिर स्विच वन तक पहुंचने के पहले पहले, ये जो यहां से जो ब्रॉडकास्ट आया है ना, वो स्विच वन तक पहुंच जाता। बिकॉज आई टेल यू व्हाई, द रीजन इज, हियर स्विच वन, sorry, switch number 3 broadcasted, it receives received by 3. Now 3, what is it going to do? It is going to read this data, it will create a new data where pc3 is the source and pc1 is the source, and it will send. Switch 3 reads that data and sends it. So by the switch, here what happens, switch number 3 has already sent the data. By the time switch number 2 forwards the data to switch number 1, switch pc number 3 is only creating a new data. जब तक स्विच 3 2 को ब्रॉडकास्ट करके, 2 उसी सेम पैकेट को ब्रॉडकास्ट करके 1 तक भेज चुका है, यहाँ पे पीसी 3 उस डेटा को रीड करके नया डेटा ही बनाया हुआ है अभी, बस। क्योंकि पीसी नंबर 3 पे भी तो प्रोसेसिंग हो रही है ना उस डेटा की।
हम्म।
तो पीसी नंबर 3 को अगर रिस्पॉन्ड करना है तो उसको नया पैकेट क्रिएट करना पड़ेगा, और नया पैकेट क्रिएट करने के लिए प्रोसेसिंग लगती है। तो उस प्रोसेसिंग डिले में ही this data is has, like anti-clockwise direction में, this data has already reached switch number 1 and it has updated the MAC entry, and because of which the original MAC entry is no more on the switching table, and the packet keeps on looping. Clear? This is
हाँ
what
हाँ
you
ठीक
call,
है।
this is
क्योंकि
what you
एल
call
टू,
as a loop.
हाँ मतलब ये कहने का मतलब कि एल टू ने भेज दिया एल1 को एल3 के पहले, तो दैट्स व्हाई इसने मैक एड्रेस में उसने ये नई एंट्री कर लिया। फिर बाद में अगेन ये ब्रॉडकास्ट किया, वो ब्रॉडकास्ट मतलब वो ब्रॉडकास्ट स्टॉर्म क्रिएट हो गया, लाइक एल टू
Correct.
लूपिंग क्रिएट हो गया, लाइक वो कंसिडरेशन अपन
Yes.
कर सकते हैं।
Yes. Yes. So this is what looping is. ये इसी को loop बोलते हैं, right? अब my question is, in an interview, how are you going to explain to an interviewer what a layer 2 loop is in 1 or 2 sentences? Okay, क्योंकि
स्विच के ऊपर, हाँ स्विच के ऊपर
हाँ,
लेयर स्विच के ऊपर स्विच इज लाइक बिलोंग्स टू लेयर टू डिवाइस, लाइक हम लोग बोल सकते हैं लाइक
हम्म,
मैक एड्रेस टेबल एंड ऑल, उसके ऊपर ये होते हैं, रन होते हैं। सो ये L2 लूप क्रिएट होता है बिकॉज ऑफ which is L2 device, L2 layer of device. So due to it, L2 loop has been created on between these two switches. और ब्रॉडकास्ट स्टॉर्म भी इसको क्रिएट हम लोग बोल सकते हैं, या स्टॉर्म भी बोल सकते हैं, काइंड ऑफ।
okay, okay. First thing, loop is not equal to broadcast. Loop is not equal to broadcast. लूप की वजह से ब्रॉडकास्ट ऑन हो रहा
ओके।
है। ओके, लूप ब्रॉडकास्ट ऑन नहीं है। बिकॉज ऑफ लूप यू सी अ ब्रॉडकास्ट। ऑलराइट, नाउ to explain, if the interviewer, if your interviewer is intelligent enough, I will give you a simple straight definition of a layer 2 loop, and that is, if if the same MAC address, if the same MAC address is seen on different interfaces, if the same MAC address is seen on different interfaces, if the same MAC address is seen on different interfaces, that means it's a loop. If in a layer 2 network, if a switch has the same MAC address entries on two different interfaces, that means it's a layer 2 loop. Simple definition. Now you know the reason why I am seeing why I am saying same MAC address on different interfaces. You know the reason behind it. That is loop. So this is a simple, straightforward answer to what a layer 2 loop is. If the interviewer is intelligent enough, he will understand. But if he asks you to explain, you can draw this diagram and explain it to him how loop is formed. And because of loop, what is the broadcast stop? You can explain it to him. All right. Now, moving on, what can be done? What can be done to avoid this loop? What can be done to avoid this loop? हम क्या कर सकते हैं जिससे कि ये लूप अवॉइड हो सकता है? लूप अवॉइड होने से वी कैन अवॉइड ब्रॉडकास्ट स्टॉर्म आल्सो. व्हाट कैन बी डन? Don't say that we can introduce spanning tree protocol. That is the solution. I'm not asking you the solution. In this particular picture, without bringing spanning tree protocol के बिना इस topology में what can we do to avoid the loop?
एक पोर्ट को शट कर देंगे, चलेगा?
बिल्कुल सही, बिल्कुल सही, absolutely right. So if I shut down this interface, let's say on switch number 3, I shut down this interface. So basically this interface is no more there. So what is going to happen now? Let's check. PC1 is sending the data to PC number 3. Okay. PC1 sends the data to switch number 1. It makes an entry and it does not find the destination MAC address. And when it does not find the destination MAC address, it is going to broadcast it. Switch number 2 receives it 1111. It was received on interface number 1. Switch 2 also does not see the destination MAC address and it will send the data only to switch number 2. Because this is shut down, this interface is shut down, the data is not going to reach switch number 3 in this direction. Okay. Then PC number 2 is going to drop this packet because MAC address is not of PC number 2. Okay. Then switch number 3 receives this packet. Switch 3 makes an entry 1111 was received on interface number 2. It does not say the destination MAC address, so it will broadcast. It cannot broadcast out of this interface because this interface is shut down. So PC number 3 receives this data. Now PC number 3 will respond. When PC3 responds, it will make an entry. 3333 is now received on interface number 3. It will see PC number 1's MAC address. It will forward it to switch number 1. Switch number 1 will see the data. It will make an entry. It was received on interface number 2. And based on the destination MAC address, it will forward. So here what happened? You have completely avoided the loop by shutting down one of the interface or blocking one of the interface. Okay, this is how you avoid a loop. It is very simple. But what if in a network there are multiple switches, not just one? Okay, you have 1, 2, 3, 4, 5, 6, 7, 8. You have such a network. Example, it's just a simple hypothetical network. Here's such a network. Okay, for example. And in this particular layer 2 network, you need to create a loop free environment. आप नहीं चाहते इस नेटवर्क में कोई भी लूप पैदा हो. So it is up to you to decide which interface should be shut down. अब आप डिसाइड करोगे कौन सा इंटरफेस शट डाउन होना चाहिए. But that's a problem. Why is that a problem? Because first, human error. Human error is the most dangerous error in the networking, because one human mistake can bring down the whole internet. That's a problem. So let's say if I shut down this interface, if I shut down this interface or this interface or this interface, hypothetically, there are chances that I may completely stop a particular traffic. I may completely stop a particular traffic, or I may introduce a new traffic. कुछ भी हो सकता है इंटरनेट पे, आपको नहीं पता. You removed one traffic, what effect it had on some other network, you have no idea. Okay, until unless आपको कॉल आने लग गई कि भाई तुमने क्या किया, तभी आपको पता पड़ता है कि भाई कुछ तो गड़बड़ हुआ. ठीक है, तो human error is the most dangerous error which you cannot risk in today's world. So what I wanted is I created a protocol called as spanning tree protocol. Called as spanning tree protocol. Okay, which is an automatic protocol to create loop free environment or loop free network. Okay, so spanning tree protocol is a protocol which helps to create a loop free network. I don't have to do anything. All I need to do is just connect two switches or multiple switches together, and they themselves will form a spanning tree loop free network. So first, spanning tree protocol on Cisco switches is enabled by default. On Cisco switches. All right, that's the first thing. Second thing, this spanning tree protocol was created. Okay, as I said, was created, as I've already mentioned, created to build a loop-free network. Loop-free. So spanning tree protocol is enabled by default on Cisco switches. Okay, I'm not aware of any other vendor because my work experience is only with with Cisco and also Sienna. In Sienna devices also you have these spanning tree protocol enabled by default. So I'm assuming in every vendor spanning tree protocol is enabled by default. This is my assumption. Okay. So I don't have to do anything. I don't have to configure spanning tree protocol. I don't have to write a मुझे कोई सिंगल कमांड लिखने की भी जरूरत नहीं. 10-15 स्विचेस को अगर मैं ज्वाइन करूं, okay, and they will start forming a spanning tree amongst themselves and create a loop free network. Okay, so now the point is how does it work? वो काम कैसे करता है? ठीक है, तो स्पैनिंग ट्री अगर मैंने 10 स्विचेस के बीच में कनेक्टिविटी बनाई and they started to run spanning tree protocol and they have started to create their own loop free network, there should be some logic. तो स्विचेस के बीच में कुछ लॉजिक चल रहा होगा जिससे कि वो एक लूप फ्री नेटवर्क बना के आपको पकड़ा रहा है. तो द थिंग इज, as I said, I don't have to do anything. The switches will automatically create a loop free network. But as network engineers, it is our responsibility to understand and know how a loop free network is created by switches. Okay, so topic is how spanning tree protocol creates a loop free network. Okay, मैंने जैसे बोला हमें कुछ भी करने की जरूरत नहीं है, सब स्पैनिंग ट्री करेगा, पर हमें पता होना चाहिए कि स्पैनिंग ट्री करता कैसे. ठीक है, बेसिकली लाइक कैलकुलेटर में मैंने क्या बोल दिया, कैलकुलेटर मैंने लिख दिया कि भाई 2+2 4, उसने लिख दिया भाई, पर +2+2 4 क्यों है, कैसे होता है, ये हमें पता होना चाहिए ना, क्योंकि हमने पढ़ा है, बचपन से हमने पढ़ा है 2+2 = 4. ठीक है, हमें लॉजिक भी पता है, दिमाग में हमें लॉजिक भी पता है वो 2+2 कैलकुलेटर 4 क्यों दिखा रहा है. ओके, बट वी शुड नो व्हाई 2+2 is 4, हाउ 2+2 is 4. That is what we are going to learn today. Okay, so spanning tree, as I said, we don't have to do anything. If I just connect 2 switches, 3 switches, 4 switches, 50 switches, 100 switches, 200 switches together, they will create a spanning tree loop free network by themselves. All right, how do they create? Let's understand. So there is a term, there is a word tree in the name, spanning tree protocol. Tree protocol. So whenever we think of a tree, how do we imagine a tree? Okay, this is my imagination of a tree. Okay, so the tree has roots. This is roots. Okay, and the tree has branches. The tree has branches, and these are the leaves. This is basically how I imagined when I tried to draw tree on my head. In my head, this is how I draw the tree. So this is the root. This is the trunk of the switch, right? And these are the branches. And on the branch, you will see leaves, right? And similarly, just like the root of the tree is the most important part. It's the most important part of the tree of a plant or any, yeah, it's basically the root is the most important part of a plant or a tree, क्योंकि यही अपन पानी क्या बोलते हैं, जड़ में या फिर रूट में डालते हैं, वो रूट पानी खींचता है एंड इट सेंड्स इट टू द रेस्ट ऑफ द ट्री. ठीक है, तो रूट इज द मोस्ट इंपॉर्टेंट पार्ट ऑफ द ट्री, क्योंकि वहां से पूरा कम्युनिकेशन जाता है, वो पानी खींचता है, पानी में जो भी न्यूट्रिएंट्स है, मिट्टी में जो भी न्यूट्रिएंट्स है, आपने खाद में जो भी मिलाया है, उसमें जो भी विटामिन है, न्यूट्रिएंट्स है, वो पानी के थ्रू द रूट it pulls up all this nutrient, it spreads it to the plant, and the plant grows into a big tree, right? Similarly, our human brain, okay, our human brain, I'm just drawing a random diagram of our human brain. So this is our human brain. The human brain, we know, is connected to the spinal cord of our body. Okay, and through the spinal cord, there are many nerves that are going to different body parts of our system. So this brain of ours, okay, is again the important, or I would say is the most important part of our body. Okay, so our brain sends signals. It sends signals, and through this nervous system, the signal goes to different parts of our body. So I am speaking, my brain is sending signals, my brain is thinking, it is sending signals, and through those signals, I'm speaking, I'm able to move my hand, I'm able to write, I'm able to speak, I'm able to listen, everything. So brain is the most important part of our body. So in other words, I can also imagine this as the root of our nervous system. मैं अपने ब्रेन को हमारे नर्वस सिस्टम का रूट मान सकता हूं, क्योंकि इस रूट से ही सभी इंफॉर्मेशन पास हो रही है। यही पूरा इंफॉर्मेशन पास करता है, समझता है, प्रोसेस करता है, सब कुछ यही करता है। अगर मेरा ब्रेन काम नहीं कर रहा, इफ माई ब्रेन इज डेड, आई एम डेड, राइट? सो ब्रेन in our nervous system is the root of our nervous system. Similarly, the root of a tree is the most important part of a tree. Similarly, in your spanning tree protocol, in your spanning tree protocol, the most important switch in spanning tree protocol, the most important switch is the root switch. Is the root switch. In spanning tree protocol, the most important switch is the root switch. So you have a big network of, let's say, 50 switches or 100 switches. Out of these 50 switches, one switch will be the root switch or the brain of the whole spanning tree protocol. Okay. Now, first thing, root switch. So the root switch, any switch cannot be a root switch. ठीक है, मतलब हमारे इंडिया में कोई भी क्या बोलते हैं, चीफ मिनिस्टर नहीं बन सकता, कोई भी प्रेसिडेंट नहीं बन सकता, कोई भी प्राइम मिनिस्टर नहीं बन सकता, या फिर स्कूल इन अ स्कूल यूनिवर्सिटी no one can be a union leader, no one can be a student leader, or no one can be a class representative. There is an election process that happens. Based on the election, based on the votes, the person becomes, or person is elected as a president, prime minister, chief minister, school, university, union leader, or a class representative. It's based on an election. Similarly, in your spanning tree network or a layer 2 network, a root switch is elected. A root switch is elected. अब इलेक्शन चल रहा है, इलेक्शन चल रहा है मतलब रूट स्विच को कुछ ना कुछ तो बेचना पड़ेगा, है ना? in normal election we have to, the candidate say something, I will do this for you, I will do that for you, I will bring this, I will bring that, etc. A lot of things. Then only the people vote for him, and that is how he is elected. Similarly, to become a root switch, you need to get the votes. Okay, to become a root switch you need to get votes, but here there is no voting. In a spanning tree protocol, there is no voting. You need to be the best. In spanning tree protocol, एक रूट स्विच को सबसे बेस्ट बनना पड़ता है, तो ही जाकर वो रूट स्विच बन सकता है. सो विच रूट स्विच इज इलेक्टेड और विच रूट स्विच इज द बेस्ट, उसका भी क्राइटेरिया. ओके, फर्स्ट, to become a root switch, the spanning tree priority of the switch should be lowest. So as I said, there are 50 switches in the network. Whichever switch has the lowest spanning tree priority, spanning tree priority. Whichever switch has the lowest spanning tree priority, that switch becomes the root switch. This is the first criteria. हमारे नेटवर्क में 50 स्विच है, इन 50 स्विच में से किसी एक को रूट स्विच बनना है, तो सबसे पहला क्राइटेरिया ये है कि जो भी स्विच का स्पैनिंग ट्री प्रायोरिटी सबसे कम है वो बनेगा स्पैनिंग ट्री रूट स्विच. ओके, नाउ स्पैनिंग ट्री प्रायोरिटी. स्पैनिंग ट्री प्रायोरिटी ranges from 1 to 65535. This is the range of spanning tree priority number. 1 is the lowest, 65535 is the highest. Okay, and the default spanning tree protocol priority is 32768. 32768. So to become a root switch, the switch should have the lowest spanning tree priority, and every switch has the default spanning tree priority of 32768. So let's imagine there are these three switches. Switch number 1, switch number 2. I will use the same diagram. Switch number 3. Okay. Now, let's say this switch number 1 has priority number 1, switch 2 has priority number 2, switch 3 has priority number 3. For example, okay, out of these three switches, switch 1 has the lowest priority, and hence switch 1 will become the root switch. Okay, this is how a root switch is elected. Now, as I mentioned, the second point, the default priority of every switch is 32768. That means in normal scenario, switch 1 will also have a priority of 32768. Switch 3 will also have a priority of 32768. Switch 2 will also have a priority of 32768. Okay. If all these switches have the same priority, then who becomes the spanning root switch? Because lowest priority is elected, correct? But here all the priority is same, then who becomes the root switch? So if priority is a tie, then lowest MAC address wins the root switch election. That means इन switches में से जिसकी भी MAC address सबसे कम है वो बनेगा root switch. Whichever switch has the lowest MAC address out of these three switches becomes the root switch in case the priority is a tie. Here, all the switches have the same priority. That means priority is a tie. In that case, out of these three switches, whichever switch has the lowest MAC address, it becomes the root switch. So here, as we are assuming 1111, 2222, 3333. So again, 1111 is the lowest MAC address out of these three switches. That is why switch number 1 becomes the root switch in our scenario. Clear how a root switch is elected? Any question? कोई क्वेश्चन कि कैसे रूट स्विच इलेक्ट होता है?
No, भाई no.
ठीक है. Now the question comes is in real world. I show in my first class I showed you the MAC, first or second class, I think second class. In the second class I showed you how does a MAC address basically look like. In real world, in real time, MAC addresses do not look like this. 2222, 3333, no, they do not look like this. They look like AB1245, like no AE, something like this. This is how they look. So in that case, like 63 or 74, 3B, D4, this is how they look like. So in this scenario, in such a scenario, or in such MAC addresses, or in real-time MAC addresses, how do we identify which is the lowest MAC address? है ना। रियल वर्ल्ड में मैक एड्रेसेस ऐसे दिखते हैं। तो भाई अगर मेरे पास ऐसे दो तीन मैक एड्रेसेस हैं, ठीक है, जिनमें ऐसे लाइक हेक्साडेसिमल फॉर्मेट में मैक एड्रेसेस लिखा है, how do I find out which one is the lowest MAC address out of those? Okay, that is my question. So let me open up Wireshark. Okay. It seems that Wireshark isn't opening. Uh, okay, let's take. No. Okay, let's take this example. These two MAC addresses. Okay, I'm assuming these two MAC addresses are real MAC addresses. Okay, and in real time we will see such MAC addresses only. So these MAC addresses are not like 111222333. ये ऐसे MAC addresses नहीं है। 111222333 होता तो बहुत आसानी से हम पकड़ सकते थे कि भाई कौन सा lowest MAC address। But in real time, this is how the MAC addresses look like. So in such a case, how are you going to identify which is the lowest MAC address out of these two? Okay. So whenever uh, two MAC addresses or multiple MAC addresses are compared, they are compared from left to right. Okay, listen to me very carefully. The MAC addresses are compared from left to right. Okay, from 0 to CC, 02 will be compared with CC, 0F will be compared with 69, B5 will be compared with FA, etc. Like this, from left to right. Each and every digit of a MAC address is compared from left to right. Okay, now let me write this down. 020F BF. 020 020F BF. 020F BF 57 7F 57 7F 63. And this is CC 69 CC 69 FA 57 FA 57 7F 63 7F. Now, how do I
बी
find out
फाइव
which is the
अभी
हाँ
बस B5
क्या
आपने BF लिखा हुआ B5 है वहाँ
B5?
पे तो क्लासिक
So now how do I find out which is a lower matrix? So as I said, every digit is compared one by one from left to right when comparing two MAC addresses, okay, in a spanning tree protocol scenario. So every single digit is compared left to right, and whichever digit is the lower becomes the lower MAC address. Meaning that, let me write down the hexadecimal format. I hope everyone remembers the hexadecimal format. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For 10, we write it as A, B, C, D, E, and F. है ना? ये है 10, 11, 12, 13, 14, and 15. Okay. Now, so as I said, each and every digit is compared from left to right. So the first digit, 0. 0 is compared with C. Who is lower, 0 or C? 0 is here. What is C? C is 12. Which is lower, 0 or C? 0 is lower, and hence this MAC address is lower. Simple. Nothing. There's nothing to worry. There's no big deal about it. Digit is compared, every single digit is compared left to right. Whichever digit is lower, that particular MAC address becomes the lower MAC address. So let's assume in this case, this again is C, for example. This is C. So C and C is compared, both are same. Then 2 and C are compared. Which is lower, 2 or C? Obviously, 2 is lower than C. So again, this particular MAC address becomes the lower MAC address. Okay. Now let's assume this is also C. This is C and this is 6F. So C and C is compared, C and C is compared, 6 and 6 is compared, all tie. CC tie, CC tie, 6 tie. Then F and 9 are compared. Which is lower? 9 is here, 9 is 9, F is 15. Which is lower? 9 is lower. So this particular MAC address becomes the lower MAC address. That is how a lower MAC address in real world is compared in a spanning tree protocol. Any question? How to find out which is a lower MAC address? Any question? No.
Okay.
All right. Now, so as I said, whichever switch, first the root switch is selected, whichever switch has a lower priority, that switch becomes the root switch. So priority is from 1 to 65535, and the default priority is 32,768. Okay, 32,768. And by default, as I said, every switches will have a priority of 32,768. So the tie is with the priority. So the next tiebreaker is lower MAC address. Whichever switch has a lower MAC address, that switch becomes the root switch. Clear? This is how your root switch is selected. So in our case, switch 1 is the root switch because switch 1 has the lower MAC address. So I'm taking this 3 switch scenario. So switch 1 here is the root switch because priority is same for all the 3 switches. MAC address is lower for 1. That is why it becomes the root switch. All right. Then the second part. Once the switches have elected a root switch, the second thing is on non-root switches. On non-root switches, elect a root port. Elect a root port. So you have switch number 1, switch number 2, and switch number 3. Switch number 1 is the root switch. Switch number 2 is the non-root switch. Switch number 3 is also non-root switch. These two are non-root switches. So on non-root switches, elect a root port, meaning that every non-root switch will have a root. हर non-root switch पे एक root port elect होगा. Now the question is, what is a root? Root port होता क्या? So short form, root port is the port. Root port is the port through which non-root switches send data to root switch. Simple. क्या लिखा है मैंने? रूट पोर्ट वो पोर्ट होता है जिससे नॉन रूट स्विच जो है रूट स्विच की तरफ डेटा भेजता है. ठीक है, रूट स्विच की तरफ डेटा भेजता है. सो 2 के पास 2 रूट पोर्ट है, एक ये है, एक ये. द switch 2 can reach the root switch through this port and through this port. Similarly, for switch number 3, it also has two root ports. It can reach this way and it can reach this way, right? But what I have mentioned, elect a root port. Elect a root port. So every non-root switch can have only one root port. Every non-root switch can have one root. Okay. So how to elect a root port? That means there will be an election between the two root. Okay. ये दोनों रूट पोर्ट बन सकते, बट इनमें से कौन सा रूट पोर्ट एक्चुअल रूट पोर्ट बनेगा, तो इसके लिए भी इलेक्शन चलता है, राइट? इफ अ नॉन रूट स्विच हैज मल्टीपल interfaces which can become a root port, an election happens, which interface will become the root. That election criteria is first, lowest spanning tree protocol cost to reach the root switch. इन दोनों इंटरफेसेस में से या फिर इन दोनों पोर्ट्स में से जिसकी भी स्पैनिंग ट्री कॉस्ट रूट स्विच तक पहुंचने की सबसे कम है, वो बनेगा रूट. सो whichever interface has the lowest spanning tree cost to reach the root switch becomes the root. Now, a new term. What is this spanning tree cost? What is this spanning tree cost? So, spanning tree cost is a predefined cost. Okay, spanning tree cost, you can see here, spanning tree cost is a predefined cost. Like this, you can see, and it is completely based on the interface bandwidth that the interface is connected. So for a 10 Mbps interface, the spanning tree cost is 100. For a 100 Mbps interface or a fast Ethernet link, the cost is 19. 1 Gbps is 4, 10 GB, 2, 21, 101, etc. like that. So what is happening? As your speed of the interface increases, the spanning tree cost decreases. Lower speed, higher spanning tree cost. Higher speed, lower spanning tree. Simple. Okay, so here it's the best. 10 Mbps is 100, 100 Mbps is 19, 1 Gbps is 4, 10 Gbps is 2, 100 Gbps is 1. Something like that. Okay, so cost is predefined. Okay, the cost is already defined. You don't have to do anything. As I said, it is calculated by the spanning tree protocol itself. It will identify what kind of interface it is. Is it a like when we were doing the practical yesterday for VLAN, we saw these interfaces: fast Ethernet 0/1, 0/3, 0/5. So these are fast Ethernet interfaces. The spanning tree already knows for a fast Ethernet interface, the spanning tree cost is 19. It automatically calculates itself. It automatically calculates itself. We don't have to do anything. So the thing is, whichever interface out of these two interfaces, whichever interface has a lower cost to reach the root switch, that switch becomes the root port. Okay. Now, for understanding sake, let us assume the spanning tree protocol cost to be 1. For understanding purpose only, let us assume the spanning tree cost is 1 for all the interface of all the switches. So here the spanning tree cost is 1, 1, 1, 1, 1, and 1. Okay. So on switch number 2, as I said, it has two ways to reach this root switch. One is this way. And through this way, what is the interface cost? We will calculate only the outgoing interface cost. So outgoing interface cost here is 1. The total cost is 1. From this point of view, the outgoing interface cost is 1 plus 1. The total cost is 2. Which is a lower cost? 1 is a lower cost, and hence this interface on switch number 2 becomes the root port. Root port. Similarly, for switch number 3, there are two interfaces to reach root port. One is this and one is this way. From this point of view, the interface, sorry, the spanning tree cost is total spanning tree cost is 1. And through this way, the total spanning tree cost is 2. And hence, this interface that is directly connected to the root switch becomes the root port for switch number 3. So whenever 2 wants to send a data to the root switch, it will use this interface. Whenever switch 3 wants to send a data to root switch, it will use this interface. Clear? Any question? How a root port is elected? Any question?
No, I know.
Now, one tricky situation comes. One tricky situation. Let me draw another diagram. Switch number 1, switch number 2, switch number 3, and switch number 4. Switch number 1 is the root switch. When switch number 1 becomes the root switch, for switch number 2, this is the root port. Switch number 3, this is the root port, obviously, because this will have a lower cost than this. Correct? Similarly, for switch number 3, the direct connected interface will have a lower cost and hence it will become the root. Now for switch number 4, this also is a root port. This also is a root port. Why? Because from this side also it is 1 plus 1, 2. Here also it is 1 plus 1, 2. So again, this time cost is a tie. In such a scenario, cost is a tie. Got it? For 4, even to elect a root port, the cost is a tie. We wanted the lower cost, but यहाँ पे दोनों तरफ से cost same है, तो root port कौन सा port बने? ठीक है? So the root port, how switch 4 decide which interface should be a root? Okay. Listen to this very carefully. Switch 4 checks its directly connected switches. Switch 4 अपने से directly connected switches को check करता है. वो है switch number 2 और switch number 3. स्विच नंबर 2 और स्विच नंबर 3 में दोनों में से जिसका भी मैक एड्रेस कम होगा वो वाला इंटरफेस बनेगा रूट. स्विच 4 चेक्स द नियर बाय स्विचेस. फॉर स्विच 4, switch number 2 and switch number 3 are the neighboring switches, and out of 2 and 3, whichever switch has the lower MAC address, that interface which is connected to the switch becomes the root port. So in our example, 2222 is the MAC address and 3333 is the MAC address. 2 is lower than 3 and hence this interface of switch number 4 becomes the root. Clear? When your cost is a tie, the switch checks the directly connected neighbors. Okay, it checks the directly connected neighbors. Out of the 2 neighbors, whichever switch has a lower MAC address, that interface becomes the root. Okay, so when cost is a tie, when cost is a tie, lower MAC of the neighbor, lower MAC of the neighbor is lower MAC of the neighbor tells which interface is going to be the root. Any question in this particular scenario with 4 switches? Such kind of a scenario.
Oh, right.
No. Now, next, third point. We have elected a root port. Sorry, we have elected a root switch, that is switch number 1. On non-root switches, we have also elected root port. Right? This is the root switch. This is the root port for switch number 3. This is the root port for switch number 2. Then third, on non-root switches, elect a designated port. Not elect a designated port, elect designated. Or I should say, designated ports. नॉन रूट स्विचेस में अब designated ports elect करना है. The criteria is on non-root switches, all ports except root port are designated port. Simple. On switch 2 is a non-root switch, switch 3 is a non-root switch. Okay, so here all ports except the root port. Switch 3 has a root port, switch 2 has a root port. So on switch 2, this is a port which is non-root port, so this becomes a designated port. On switch number 3, this becomes a designated. Okay, so let's say if there are, this is a root port for this switch, and there are multiple interfaces that are connected to this switch. So this interface becomes a designated port, this 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 becomes a designated. Okay. Now the question comes, what is a designated? What was a root port? Root port क्या था? जिस इंटरफेस से मैं root switch पहुंच सकता हूं वो है root. Root port is the port through which we can reach the root. Similarly, designated port. What is a designated? Through designated port, non-root switches can reach other non-root switches. Non-root designated port से एक non-root switch दूसरे non-root switch को reach कर सकता है. Through a designated port, one non-root switch can reach other non-root switch. So here, switch 2 is a non-root switch. It can reach switch 3 through its designated port. Switch 3 is a non-root switch. It can reach switch 2 through its designated. That is what the work of a designated port is. Okay. So, whichever interfaces except root port are designated port on non-root switches. But on a root switch, all ports are designated. What is the definition of a designated port? Designated port की definition क्या है? मैं दूसरे non-root switches को पहुंच सकता हूं. मैं खुद root switch हूं. I am the root switch. That means all the other switches are non-root switches for me. That is why this is a designated port for me. This is a designated port. Clear? Any question? How to find designated port? Any question?
इसमें लक्ष्य आप बोल रहे हो ऑल पोर्ट्स आर डेजिग्नेटेड पोर्ट, तो उसमें ऑल पोर्ट मतलब रूट स्विच में ऑल पोर्ट्स आप डेजिग्नेटेड पोर्ट बता देंगे तो रूट पोर्ट कैसे बताएंगे?
ओके.
या इसमें आप ये बता सकते हैं कि रूट स्विच से कनेक्टेड डायरेक्टली कनेक्टेड पोर्ट वी कैन कॉल एज डेजिग्नेटेड पोर्ट.
नो, मैं ये बोल रहा हूँ रूट पोर्ट का डेफिनेशन क्या था? रूट पोर्ट का डेफिनेशन ये था कि भाई नॉन रूट स्विचेस रूट स्विच की तरफ पहुंचते हैं.
बरोबर.
मैं खुद रूट स्विच हूं तो मेरे में रूट पोर्ट थोड़ी ना होगा. नॉन रूट स्विचेस रूट पोर्ट यूज करके मेरे पास आ.
बरोबर.
मैं खुद रूट स्विच हूं तो मेरे पास रूट पोर्ट नहीं हो. ओके, पहला. सेकेंड थिंग, डेजिग्नेटेड पोर्ट का मतलब ये होता है कि मैं भले रूट स्विच हूं या नॉन रूट स्विच हूं, मैं दूसरे नॉन रूट स्विचेस तक डेजिग्नेटेड पोर्ट यूज करके पहुंच सकता हूं. स्विच 1 रूट स्विच है, वो खुद रूट स्विच है तो मतलब बाकी सभी नॉन रूट स्विचेस है, तो उस पे तो सभी डेजिग्नेटेड पोर्ट ही हुए ना. सिमिलरली स्विच 2 के लिए ये डेजिग्नेटेड पोर्ट है क्योंकि इससे वो स्विच 3 पहुंच सकता है, स्विच 3 के लिए ये डेजिग्नेटेड पोर्ट है क्योंकि वो स्विच 2 पहुंच सकता है, क्योंकि दोनों नॉन रूट स्विच। क्लियर?
क्लियर।
नाउ but after all these things also, loop free network is not created. A loop free network is still not created after all these things. We have elected a root switch, we have found out a root port, we have found out designated port, but still a loop free network is not formed. A loop free network is not. So to create a loop free network, you should block interfaces, just like what you had said in this example. If we shut down this interface, loop is completely avoided. That means you need the spanning tree protocol needs to block interfaces in order to create a loop free network. So which interfaces to block? मतलब स्पैनिंग ट्री प्रोटोकॉल को इंटरफेसेस को ब्लॉक करना पड़ेगा लूप फ्री नेटवर्क क्रिएट करने के लिए। तो कौन से इंटरफेस को मैं ब्लॉक करूं, ये स्पैनिंग ट्री कैसे पता करे वो दे।
डेजिग्नेटेड पोर्ट वाले।
राइट, ओके। सो द फोर्थ इज elect elect block ports. Okay, so the election criteria of a block port is switch number 1, switch number 2, switch number 3. Switch number 1 is a root switch. Let me, instead of this green color, let me use a black color. Switch number 1, switch number 2, switch number 3. Okay, this is a root switch. This is a root port. This is a root port. This is a designated port on a root switch. This is a designated port on a root switch. This is a designated port on a root switch, and this is a designated port on a non-root switch. Sorry. So where do we elect a block port? Okay. Election, or not election, a block port. Block port is elected where there are where where there is a designated port to a designated port connectivity. Okay. ब्लॉक पोर्ट वहां इलेक्ट होता है जहां पे डीपी कनेक्टेड होता है, डेजिग्नेटेड पोर्ट कनेक्टेड होता है, और कहीं नहीं होगा। सो इन दिस सिनेरियो you have here you have designated port root port connectivity, you will not elect a block. Here you have a designated port root port connectivity, no block port election. In this network or in this link, you have a designated port connectivity. This is where you will have to find out which interface should be blocked. Which interface should be blocked. Okay. So now, okay. So how to find out which interface should be blocked? Switch with higher cost to reach the root switch will change its designated port to block port. जो भी स्विच की रूट स्विच तक पहुंचने की कॉस्ट ज्यादा होगी, वो अपना डेजिग्नेटेड पोर्ट को ब्लॉक पोर्ट बनाए। In this example, switch 2 has a cost of 1 to reach the root switch. Switch 3 also has a cost of 1 to reach the root switch. So in our scenario, both the switches have a same cost. So cost is a type. So in this scenario, in our scenario, cost is a type. This ये scenario हर बार नहीं होगा, कोई स्विच का रूट कॉस्ट ज्यादा होगा तो वो अपना पोर्ट ब्लॉक कर लेगा. But some scenarios have situation where the cost is a tie. That scenario, what will happen? If cost is a tie, next is switch with higher MAC address. Higher MAC address will convert its designated port to block port. अगर cost tie होता है तो जो भी switch का MAC address ज्यादा है, it will change its designated port to block. Okay, so in this case, switch 1 has a MAC address of 111, 222, 333, etc. So between 2 and 3, which switch has a higher MAC address? It is 3. That is why switch 3 will change its designated port to a block port. And with this, you now have a spanner tree now has created a loop tree network. This is the exact step-by-step process of how a spanning tree creates a loop tree network. Whatever steps that I have mentioned, I don't have to do anything. You don't have to do anything. No one has to do anything. All of this is done by the spanning tree protocol, which is enabled on the switch. So, as I said, if you connect multiple switches together, they will first elect a root switch, then elect root port, then elect designated port, then elect block port, and they will give you a loop free network. Okay, so let's recap. Let's recap. In a loop free, to create a loop free network, what does a spanning tree does? It first elects a root switch. How a root switch is elected? Whichever switch has the lowest spanning tree priority, it is chosen as the root. And by default, every switch has a priority of 32,768. And if the priority is a tie, whichever switch has a lower MAC address, it is chosen as the root. Once the root switch is elected, on non-root switches, a root port is elected. What is a root port? Root port is the port through which non-root switches send data to the root switch. So on a non-root switch, you can have multiple root ports, but whichever port has the lowest spanning tree cost to reach the root switch, it is chosen as the root port. If cost is a tie, then the lowest MAC address of the neighbor is chosen as the root port. Sorry. That interface is chosen as the root, which I had shown you with this example. Now, after a root port is elected, designated port on non-root switches is elected. All the ports except the root port is designated port on non-root switches. On root switch, all ports are designated. Okay. Then we need to create a loop-free environment, not we. Spanner tree needs to create a loop-free environment by electing a block. Whichever switch has a higher cost to reach the root switch, it will convert its designated port to block port. If cost is a tie, whichever switch has a higher MAC address will convert its designated port to block. Okay. Any question?
No, I know.
No. Okay. So let's take a break of 15 minutes. Okay. And we will start and we will resume the session at 12.
ठीक है. Okay.
So, as I said, I will. Okay. Here I have a switched network. Okay. And what we are going to do is what we learned till now, electing a root switch, root port, designated port, block port. It was only with 3 switches, and it was very easy to find out. Okay. But what if we have such a network and we have been given this topology? Okay, and we have to find out on the paper what a loop-free network would look like, because in real world, you will not be able to see the switches. You will not be able to see the connectivity. All you can do is simply go type show commands and check which is a root switch, etc. But when you have a topology diagram with you, and when you know the MAC addresses, the IP addresses, you have that data sheet with you, you should be able to find out, or you should be able to create or draw a loop free topology and verify it with the network. So for that, as I said, spanning tree knowledge is required. So for this one, what we are going to assume, first thing as usual, assumption number one, MAC addresses of all the switches are like 11112222, etc. Like this. Okay. Then the priority of spanning tree priority of all the switches is 32768. Right. Then the third assumption is spanning tree cost. Spanning tree cost for all interfaces is one. This is what these three are the assumptions that we are going to make. And then we will try to solve this loop free network. Okay. This is very helpful from a real time perspective, also from an interview question perspective. Okay. So if I tell you, I was in an interview when I had just 3 or 4 years of experience, and the interviewer drew a spanning tree network on a paper, and he gave me some MAC addresses, priority, etc. And he asked me to draw the loop free network. So you may also face such questions in the interview. You should be very prepared, and you should have a good knowledge of these processes of electing a root switch, root port, designated port, block port. Then only you will be able to draw a loop free network. So let's do that. So first thing, we have to elect a root switch, correct? Elect a root switch. And we know that for electing a root switch, the priority is considered. First is the lowest priority. And we are considering every priority of the switches to be 32768. So what is going to happen? All the switches are going to have the same priority. So priority is a tie. If priority is a tie, the next tiebreaker is lower MAC address. Whichever switch has a lower MAC address becomes the root switch. And in this scenario, we have taken the MAC addresses like 1, 1, 2, 2, 3, 3, etc. So obviously, our root switch is this switch, switch number 1. All right. Then second thing, we have to find out what we have to find out root ports on non-root switches. So all these switches are non-root switches, correct? So we have to find root port. And we know that root port is the port through which these switches will reach or send the data towards the root. Okay, so let's start. On switch number 2, we have 1, 2, 3 interfaces which can be a root port. But out of those root switches, only one will be a root port. Sorry. So the root port criteria is lowest cost to reach the root switch. Which interface has a lower cost to reach the root switch? So this is 1 plus 1, 2. This is also 1 plus 1, 2. Okay. Do we have any other costs? This is 1 plus 1 plus 1 plus 1. Obviously, this interface will not be considered. We have another way, 1 plus 1 plus 1, 2, sorry, 3. So we have multiple paths to reach the root switch, but the lower cost interfaces are 2 interfaces where the cost is only 2. That is this interface 1 plus 1 and this interface 1 plus 1. Okay. So lower cost. Both do not have a low cost. Cost is a tie. That means the next criteria is this switch will check its neighboring switches. In this way, we have 4 and 8. These two are neighboring switches, whichever switch has a lower MAC address, that interface becomes the root port. So this is 4444, this is 8888, and hence this interface will become the root port for switch number 2. Okay, the next switch number 3. 1, 2, 3. Obviously, the directly not okay. This is not directly. Let's see which is the root port. 1 plus 1, 2. 1 plus 1, 2. Then we have any other 1 plus 1 plus 1 plus 1. No, we are not going to consider. So again, we have 2 interfaces which can be a root port. the cost is a tie, right? Cost is a tie. 1 plus 1, 2, and 1 plus 1, 2. So for 3, which are the two neighboring switches? 9 and 4. Out of these two neighboring switches, which has a lower MAC address? 4 has a lower MAC address, right? So this interface becomes the root. This interface becomes the root. So what I'm going to do, green is root port. Okay, green is the root. So I will delete all the other drawings. Green is root. Now let's check 4. For 4, directly connected interface will always be a root port. So this is the root port. Then 5. For 5, how many paths are there? 1 plus 1, 2. Then 1 plus 1 plus 1, 3. Then you have another way. 1 plus 1, 2. Again, there are two ways for switch number 5 to reach the root switch where the cost is a tie. 1 plus 1, this one, and 1 plus this one. 2 paths. So 5 will choose which is a lower MAC address. 6 has a lower MAC address. So this interface becomes the root port. Okay, root port. Got it? Then let's go to 6. For 6, directly connected interface is a root switch, right? Then for 7. For 7, 1, 2. 1, 2. Again, that's a tie. 1, 2, that's a tie. So 7 will again choose C, which is lower MAC address, 6 or 8. 6 has a lower MAC address. That is why that interface for switch number 7 becomes the root port. This interface becomes the root. Then you have 8. For 8, directly connected interface becomes the root port. For 9 also, directly connected interface becomes the root. For 10, there are 1, 2, 3. Then again we have 1, 2, 3. We have 1, 2, 3. Okay. So again, you have two interfaces from both sides. You have the cost as same, that is 3. So which interface will become the root port? Which interface becomes the root port? So 10 will see which has a lower MAC address, 3 or 2. 2 has a lower MAC address, and hence, okay, 2 has a lower MAC address. From between 2 and 3, 2 has a lower MAC address. So this interface becomes the root. Clear how a root port is elected? Root port is not elected based on, let's say, for 10. 10 ये चेक नहीं कर रहा कि मेरे से कौन सा मैक एड्रेस कम है, नहीं. 10 ये चेक कर रहा है मेरे जो दो नेबर्स हैं, 3 मेरा नेबर है, 2 मेरा नेबर है, इन दोनों के बीच में लोअर मैक एड्रेस किसका है, वो ये चेक करता है रूट पोर्ट इलेक्ट करने में जब कॉस्ट सेम हो. ओके, सो 10 is checking out of the two neighbors which has a lower MAC address. That interface becomes the root port. Okay. Next, elect designated port. Designated port. Which is a designated? We know on non-root switches, all interfaces except the root port. On non-root switches, all interfaces except the root port is a designated. So on switch number 2, this is designated port. Designated port. Switch number 3, where is switch number 3? Here. Designated port. Designated port. Switch number 4. DP. 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 Switch number 5. DP. DP. Switch number 6. DP. DP. 7. DP. DP. 8. DP. 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 9. DP. DP. 10. DP. Okay. These are the designated ports of non-root switches. And on root switches, everything is a designated. All right. Fourth, block port. Now find the block port. We know the criteria for block port is wherever you have a DP to DP connectivity, you will find the block port. Okay. So starting from 1, between 1 and 9, you have DP-DP connectivity? No. Root port, designated. Between 1 and 4, root port, designated. Between 1 and 8, root port, designated. Between 1 and 6, root port, designated. So this clearly shows you that with root switch, if any device is directly connected to root switch, it will never have a block. And every devices that is connected to the root switch will be connected via its designated port. Sorry, will be connected via its root port only. See, 9 is connected to root port to the root switch, 4 to the root port, 8 to the root port, 6 to the root port. So with root port, sorry, with root switch, all the devices are connected to root port only. And it is always a root port designated port connectivity. No block port connection to the root switch. Okay. Then coming to 2, do we have a DP-DP connectivity? This is root designated port, root port. No. Root port designated. No. This is designated port, designated. So between these two interfaces, we will have to choose which is a block. So first, higher cost to reach the root switch. Let's see, 2. What is 2's cost to reach the root switch? 1 plus 1, 2. What is 8's cost to reach the root switch? 1. So 2 has a higher cost to reach the root switch, and hence 2 will convert its designated port to a block. Okay. Then coming to 3. Root port, designated port, no problem. You have 3 and 10. DP-DP connectivity, you will have to choose a block port. So which switch has a higher cost to reach the root switch? 1 plus 1. Again, this is again 1 plus 1 plus 1. So 10 has a higher cost to reach the root switch, and hence 10 will change its interface to block. Okay. Then we have between 3 and 9. 1 plus 2 and 9 has a direct connectivity. So 3 has a higher cost to reach the root switch, and hence between 3 and 9, 3 will change its interface to block. Okay. Then coming to 4. 4 is here. Root port designated port, no problem. Root port designated port, no problem. Root port designated port, no problem. Then you have designated port, problem. Okay. So here you have to choose block port. 4 has a direct connectivity. 8 also has a direct connectivity. So cost is same. Cost is same. Then between, when cost is same, which switch has a higher MAC address? 4 has a higher MAC address or 8 has a higher MAC? Obviously 8 has a higher MAC address. So 8 will convert its designated port to block. Okay. Then 5. 5 has multiple designated ports. Okay. So yeah, between 5 and 9. 5 and 9 we have to choose the block port. So for 5, what is the cost? 1 plus 1, and for 9 this is 1. So 5 has a higher cost to reach the root switch, and hence 5 will change its interface to block. Okay. Then between 5 and 7 also we have DP-DP connectivity. So let's check. 1 plus 1, 2. Again for 7 also 1 plus 1, 2. Which cost is a type? When cost is a type, higher MAC address. 7 has a higher MAC or 5? Obviously 7 has a higher MAC, so 7 will convert its designated port to block. Then let's come to 6. 6 has a root port designated port connectivity, no problem. Root port designated port connectivity, no problem. Designated port root port connectivity, no problem. Coming to 7, we already have a block port here. Then between 7 and 8, we need to choose the block port. 8 has a direct connectivity to 1. 7 has non-direct connectivity. So obviously 7's cost to reach the root switch is higher, and hence 7 will convert its designated port to block. Okay. Then coming to 8, we have already chosen, we have already configured everything on 8. Then coming to 9, for 9 also we have done everything. Okay. root port, designated port, block. For 10 also, everything is done. Now, okay, now let me remove all the block interfaces. This, 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 and this. This is your loop-free network for spanning tree protocol. This is the loop-free network for spanning tree protocol. Okay, so in this case, if you see designated port, with designated port, a root switch or a non-root switch reaches other non-root switches. Okay, let's go one by one. Root port. What is a root port? A non-root switch will send data towards the root switch. Look at 5. 5 can reach the root switch through its root port only. 6 can reach the root switch through its root port only. 7 can reach the root switch only through its root port only. 8 can reach the root switch through its root port only. 3 can reach the root switch through its root port only. Okay, so clear? With root port, non-root switches will reach the root switch through its root port. Okay, then designated port. Non-root switches will reach other non-root switches or send data towards other non-root switches through the designated port only. Okay, first, this is not true every time. ये सभी टाइम ट्रू नहीं होता. मैंने क्या बोला, एक डेजिग्नेटेड पोर्ट से एक नॉन रूट स्विच दूसरे नॉन रूट स्विच की तरफ डेटा भेजता है. ये हर वक्त सही नहीं होता. Depend on the topology as well. Okay, so if I have to give you an example, 5 is a non-root switch. If it wants to reach 8, it still has to send the data to the root port only. It will send the data like this and it will reach here. But if 4 wants to reach, 3, 10, or 2, it will send data through its designated port only. Okay, so depending on the topology, the designated port may be used to send the data towards other non-root switches, or it may use other non-root switches may use the root port to send the data towards other non-root switches. So if 5 wants to reach 10, it will send the data like this only. If 3 wants to reach 9, it will send the data like this only. So 3 is a non-root switch, 9 is a non-root switch, but still 3 has to use its root port to reach non-root switches because of the loop-free network. Okay. But for 4, if it wants to reach non-root switch, it can use its designated port, or it may use a root port to reach other non-root switches. Clear? Any question of how a spanning tree finds a loop-free network? Any question?
भाई लक्ष्मी like simple question था. मतलब designated port रहेंगे. So first criteria will be cost and second will be MAC वाला, right?
Designated port में कोई criteria नहीं.
हाँ नहीं, designated जो पोर्ट रहते हैं, designated पोर्ट जो रहते हैं हम लोग सेलेक्ट करते हैं ना उसमें रूट.
अच्छा, उनके बीच में ब्लॉक पोर्ट, उनके बीच में जो ब्लॉक पोर्ट सेलेक्ट
ब्लॉक पोर्ट जो सेलेक्ट करते हैं, फर्स्ट विल बी कॉस्ट एंड सेकंड विल बी मैक एड्रेस, राइट?
मैक, पर दोनों हायर कॉस्ट हायर मैक.
या ठीक है,
करेक्ट,
यही था. बाकी वो वीडियोस देख लूंगा मैं.
हाँ ठीक, नो प्रॉब्लम. सो फर्स्ट इज हायर कॉस्ट, देन हायर मैक
एड्रेस.
एंड दिस. Okay, so this is how the spanning tree protocol will find out the loop-free network. So let's say if you have a diagram with you, you should find out the loop-free network by creating your own topology, and then you should verify it with the network also. Otherwise, you will not be able to go through the network, because let's say there is a problem on this switch number 9, for example, switch number 9. Okay, and you are sitting on switch number 5. You will not be able to log into switch number 9 directly, because this interface is blocked. You cannot send, you cannot do a CDP, you cannot do a telnet to switch number 9. You have to you have to do a telnet to 6, then you have to do a telnet to 1, then you need to do a telnet to 9. Then only you will be able to reach switch number 9. So you should have a diagram with you. And to create that diagram correctly, you should know how a spanning tree works. And as I said, I don't have to do anything. मुझे कुछ नहीं करना है. आप जैसे ही ये सभी स्विचेस को एक दूसरे के साथ कनेक्ट करोगे, स्पैनिंग ट्री अपने आप एक लूप फ्री नेटवर्क बनाएगा. वो लूप फ्री नेटवर्क कैसा दिखता है आपको पेपर में पता होना चाहिए, राइट? दैट इज व्हाई आई एक्सप्लेन्ड ऑल दीस स्टेप्स. Okay, so any question how to find root switch, how to find root port, designated port, block port, any question?
नो भाई नो. और ना भाई मेरे को एक क्वेश्चन बताना, लाइक सिस्को डिवाइसेस विल ऑटोमेटिकली सेलेक्ट ऑल द थिंग्स, राइट?
Correct, correct. Not just
These are
Cisco
the
switches.
applicable.
I'm assuming it is with every vendor. I'm assuming
Huawei
it
and
is with
all.
every. I'm assuming with every vendor, the spanning tree is enabled by default. Okay, so that is why, because spanning tree is enabled by default, the moment you connect two switches together, they start to elect root switch, root port, etc. So spanning tree is already running. When the moment you let's say you buy a switch from Cisco and you powered it on, switch will automatically start to run spanning tree protocol, trying to see which are the interfaces that have connection. स्विच आपने खरीदा, उसको प्लग किया, पावर किया, स्विच ऑटोमेटिकली ढूंढने लगेगा भाई कौन कौन से इंटरफेसेस है जहां पे प्लग सॉरी केबल लगे हुए, वहां पे मैं स्पैनिंग ट्री चलाना शुरू करूं. ये खुद ब खुद ढूंढने लगेगा. यू डोंट हैव टू डू एनीथिंग, बट वी शुड नो द प्रोसेस. Okay, it's just like in let me open up calculator. So let's say I did 25 into 25, for example. It gave me the answer 625. Okay, but 625 is okay, but I should know how did it calculate. So I should know how to do multiplication, how to do a multiplication. I should know that. Right, then only I will be able to find out why the answer is 625. That is what I have taught you. Spanning tree protocol, the moment you connect multiple switches together, it will give you the answer 625. But you should know how 625 was done. Okay, and I found a very good method. Like when I was, मुझे नहीं पता आप लोग को पता है कि नहीं, बट अगर कोई भी नंबर, मैं 2 digit नंबर की बात कर रहा हूँ, मैं 3 digit नंबर की बात नहीं कर रहा. आई एम जस्ट टॉकिंग अबाउट 2 digit नंबर. लेट्स से यू हैव 15 एंड यू वांट टू फाइंड आउट द स्क्वायर ऑफ 15. ओके, एक ऐसे डाइवर्जन टॉपिक से थोड़ा हट के मैं चीज बता रहा हूँ, तो आपको कुछ नहीं करना है. 5 का तो 25 होता है. 1 के बाद जो नेक्स्ट नंबर आता है 2, 1 और 2 को मल्टीप्लाई करो. ठीक है, 1 इंटू 2 225 है इसका आंसर. सिमिलरली अगर आप 25 करते हो, 25 इंटू 25, 5 होता है, 2 3 6 625 इसका आंसर. ठीक है, अगर आप मान लो कि आप 75 करते हो, इफ यू डू 75 5 into 5 is 25, 7 8 is 56. This is the answer. Okay, fun way. Now let's do a practical about it. Okay, but when I'm doing the practical, मैं इतने 10 switches को लेके कनेक्ट नहीं करके करने वाला. ठीक है, 4 switches यूज करूंगा, सिंपल सा टोपोलॉजी यूज करेंगे. See, the thing is, we have to understand the concept. We don't have to complicate the concept. ठीक है, सिंपल टोपोलॉजी यूज करके भी आप कॉम्प्लेक्स चीजें समझ सकते. Okay, so when learning complex thing, Keep the concept clean. Keep the concept small. Okay. That is how you basically learn bigger concept or advanced concept. So what I will do, let me first show you how loop is formed. Switch number 1, 2, 3, and 4. See, the moment I started connecting these switches together, they have started to run spanning tree protocol among themselves. I'm not doing anything. I am not doing anything. These switches are running spanning tree protocol amongst themselves. Okay, and you will see these switches slowly will turn their interfaces green, and one of the interface in this topology will be yellow, or sorry, orange. That interface is blocked. See here, all the devices are turning their interfaces to green. That is, they are finding root switch, root port, designated port, etc. This interface you see is still orange. That means this interface is blocked. Simple in the topology over here. Okay, but I wanted to show you loop, right? I wanted to show you loop. So what I will do, I will remove, as I said, on Cisco switches, spanning tree is enabled by default. So what I will do, I will remove spanning tree as of now to show you the loop. To remove spanning tree, you can just do configuration terminal, no spanning tree, VLAN 1. Okay. Why VLAN 1? Because as we know, all these switches interfaces are working on VLAN 1, are connected on VLAN 1. So spanning tree is also running on VLAN 1 only. That concept I will teach you when we are learning TVST protocol, per VLAN spanning tree protocol. I will explain that concept when we go there. Configuration terminal, no spanning tree, VLAN 1. Switch number 3, configuration terminal, no spanning tree, VLAN. And switch number 4, configuration terminal, no spanning tree, VLAN. Okay. So you can see here, all the switches have their interfaces turned green. No spanning tree is running on the switches. And we can see switches MAC address table, show MAC address table is empty. Empty, these switches know about each other's MAC address only, not an end device. They know about each other's MAC address only, not from end device. Okay. Now, what I will do, I will introduce a PC here. Okay. Add. Okay. You can still see the interfaces are solid, solid triangle with up. Let me add a IP address to it. Let me add an IP address to it. 10.0.0.1. The moment I press enter, you will see these interfaces blinking. Can you see? The interfaces are blinking. That means a loop is formed from Cisco packet tracer's perspective. Let's check. What is the MAC address of PC number 1? 1614. It ends with 1614. Okay. So on switch number 1, let's check the show MAC address table. Show MAC address table. 1614 is received on 0/2, 0/1, 0/2, 0/1, 2, then 1, then 2, then 1. 1614 is received on 1, then 2, then again 2, change to 1, then again 2. So that, as I said, when the same MAC address is received on two different interfaces, a loop is formed. You will see the same on switch number 2, switch number 3 here as well. Show MAC address table 1614 0/1, 1614 2 2, then 1 2 1 1 1 1, still 1 2, and then it went back to 1. So you see here. So same MAC address is received on two different interfaces. A loop is formed. Okay, and because of the loop, what we will see? A broadcast tom. A broadcast tom. Okay, and to avoid this particular broadcast tom or loop, what do? We bring in spanning tree protocol. So let me enable spanning tree protocol one by one. Configuration terminal, spanning tree protocol, VLAN 1. On switch number 2, configure spanning tree VLAN 1. On switch number 3, configuration terminal, spanning tree VLAN 1. And on switch number 4 also, spanning tree VLAN. So I have introduced spanning tree protocol on all these switches, and you will see one by one the switches will turn their interfaces green, and one interface out of all these four switches will be orange, that is block. And also remember, these interfaces are fast Ethernet interfaces, 100 Mbps interfaces. And I showed you for spanning tree protocol, 100 Mbps interface will have a cost of 19. Cost of 19. So we will see a cost of 19 in all these interfaces. Okay. I'm waiting for these three interfaces to make some decision. Something is wrong with these switches. So let me just disable and enable the spanning tree. No spanning tree VLAN 1. Then spanning tree VLAN 1. Configuration terminal. No spanning tree VLAN 1. Spanning tree VLAN 1. Configuration terminal. No spanning tree VLAN 1. Spanning tree VLAN. Something is wrong between these three switches. They were not coming up. So that is why what I did, I disabled spanning tree and enabled spanning tree once again, so that the election criteria happens once more. And if that does not happen, I will completely remove all these switches and bring in new switches. But the concept remains the same. I showed you how the looping is formed.
अच्छा ये लक्ष्य ये इसमें एक स्विच में लॉगिन करके 100 लॉग्स करेंगे तो आपको उसमें मैक क्लास का दिखेगा लॉग्स, राइट?
ये स्विच में शो लॉगिंग होगा।
मैक जो फ्लडिंग हो रहा है वो दिखेगा ही ना, मतलब आपको जो डबल डबल मैक आप बोल रहे थे। जैसे नॉर्मल
इसमें
पे हम लोग देखते
नहीं,
हैं।
डुप्लीकेट लाइक फॉर डुप्लीकेट एड्रेसेस or for Mac flapping, there is no logs. And I think this in Cisco Packet Tracer on switches, I don't think you can check logs. So log.
So normally what happened, like 9300, we were able to log in and then find out like back flapping will be happening. So हम लोग उसमें kind of LHCP है, क्या करना है क्या नहीं, बेसिक स्टार्ट ट्रबल शूटिंग। तो उसमें हम लोग को क्या करना रहता है तो हम लोग कर लेते हैं। तो लॉगिंग ही है, तो लॉगिंग में ही आ जाते हैं।
हाँ वो मैं समझ गया, बट ये स्विच का है ना, शो मैक एड्रेस टेबल ये। नहीं, इस ये जो भी स्विच का मॉडल है, क्या switch? तो ये वर्चुअल इमेज भी है ना ऊपर से। So,
तो मे भी इसमें नहीं देखेगा, ये एंड ऑफ लाइफ,
इसमें
एंड ऑफ
शायद नहीं
सपोर्ट।
दिखेगा, हाँ इसमें शायद नहीं दिखेगा। प्रॉब्ली रियल डिवाइस में दिखे, इस डिवाइस में नहीं दिखे। तो क्या गड़बड़ है यार, मेनू का आना चाहिए। So okay, let me do one thing. Let me create a fresh, me bring in fresh switch. Switch 5, 6, 7, and switch 8. Okay. So all the switches are up, interfaces are up, and you can see one interface is orange. That means this interface is blocked. Okay. Now this interface is blocked. Now let's go one by one of how these four switches would have formed the loop-free network. Okay. So let's go on switch number 5. Let's first of all find out which is the root switch. Okay. To find the root switch, we need the MAC addresses and priority. And as I said, on Cisco switches, the priority is same. Show, span tree, active. You will see that the priority is 32,769. It says 769, but we have to take it as 768. Why is it 9? I will talk about that later. Okay. Consider it as 32,768. Okay. So when 32,768, what will be the uh, all the switches obviously will have 32,768 as the priority. So we have to go for the MAC address. So let me note down the MAC addresses of each switch. Okay. So copy. This is for switch 5. For switch 6, for switch 7, and switch 8. Let us bring their MAC addresses. So switch 5, let's go to switch 6. Show version, and this, okay, we are also checking base Ethernet MAC addresses. Okay, let me tell you, there are two types of MAC addresses. One is an one is an interface MAC address. The other is the base Ethernet MAC address. So we are checking the switches MAC address, not switches interface MAC. Switch interfaces also have MAC addresses. We are not checking the interface MAC addresses, but we are checking the switches base MAC address. All right. Let's go to switch 7. Okay. Now let's find out which switch will be the root switch. Priority for all the switches is same. So that's a tie. Second thing, which switch will be the root switch based on lower MAC address? So as I said, we will compare left to right, digit by digit. So 00 is same. Then E0, E is obviously larger than 0. So switch 5 and switch 8 are out of the race for becoming the root switch. Then you have 0, 0, that's a tie. 0, 0, 0, that's a tie. 0, 0, 0, that's a tie. 1 and B, which is lower? Is 1 lower or B? B is 11, 1 is 1. So obviously this MAC address, 1 is lower, and hence this MAC address is the lowest MAC address, and hence switch 6 will be the root switch. So let's check. Let's go to switch. This is 5, this is 6. So let's go to switch 6 and check. Enable, show, spanning tree active. You can clearly see root ID is 32769. This is switch 6 MAC address, and it says this bridge is the root switch. This bridge or this switch is the root switch. Okay, so switch 6 is the root switch, correct? Now let me copy this. Switch 6 is the root switch, correct? This is the root switch. All right. Now, if this is the root switch, the second step, on non-root switches, we have to find root port, correct? On non-root switches, we have to find root port. Switch 7, this is switch number 5, switch number 6, switch number 7, switch number 8. So on switch 6 is the root switch. On switch 5, which will be the root port? Obviously, the directly connected interface is going to be a root port. Switch 7 also, this interface is going to be a root port, correct? Let's check on switch 5 and switch 7. On switch 5, show spanning tree active. Okay. Root port, fast Ethernet 0/1. Fast Ethernet 0/1 is the root port. Okay. Fast Ethernet 0/7 on switch 7 is also the root port. Fast Ethernet 7, show spanning tree active. Fast Ethernet 0/1 on switch 7 is also the root port. So our understanding of root port election is correct. Then on switch 8, which will be the root port? This or this? Let's check. So we know that to elect a root port, cost is considered, which has a higher cost, correct? One, this is 19. Okay, as I said, all of these interfaces are 100 Mbps link, and on a 100 Mbps link, spanning tree cost is 19. Okay, so cost is 19 plus 19. Here also cost is 19 plus 19. That's a tie. Cost is a tie. When cost is a tie, next is the neighboring switch. Which neighbor switch has a lower MAC address? Switch 7 has a lower MAC address or switch 5 has a lower MAC address? Let's check. Switch 5 has a lower MAC address or switch 7 has a lower MAC address. Okay, 0, 0, 0, 0, tie. E and 0. Obviously, 0 is lower than E. So this switch 7 has a lower MAC address, and that is why you will see this is switch number 7, this is switch number 5. Switch 7 has a lower MAC address, and hence this interface is the root port. Clear? Then next, all interfaces except root port are designated. Designated port, designated port, designated port, designated port, designated. Okay. Then block port. Wherever there is DP-DP connectivity, we have to find out. No DP-DP connectivity, no DP-DP connectivity, no DP-DP connectivity. We have a DP-DP connectivity here. So out of these two switches, one of them has to convert its interface as a block port. Okay. To convert a block port, first, higher cost is checked. Correct? Cost of switch 5 to reach root switch is 19. Cost of switch 8 to reach the root switch is 19 plus 19, 38. So obviously, switch 8 has a higher cost to reach the root switch. Okay, so this is DP, this is DP, and because switch 8 has a higher cost to reach the root switch, it has converted its interface to a blocked interface. So let's go on switch number 8. Enable show spanning tree active. You can see fast Ethernet 0/2 on switch 8 as orange. Orange is block state. Block state. Fast Ethernet 0/2 is block state. Clear how spanning tree is automatically creating a loop free network? Any question? No question? All right.
No.
Now let's go to the practical and check some commands. On switch number 5, we can see when I do a show spanning tree active, what does it? It says that it will show the all the active spanning tree instances for VLANs, different VLANs. So as I had shown you earlier, when I do a show VLAN, all the interfaces of a Cisco switch are by default part of VLAN number 1. And hence, when we enable a spanning tree, okay, the spanning tree is enabled for VLAN number 1 only. It is enabled for VLAN number 1 only. So as you create more and more VLAN, and if you want spanning tree to be enabled on that VLAN also, you have to enable that. Like, let's say I configured VLAN 10. So VLAN 10 is created. Show VLAN. VLAN 10 is created. Okay. But let me check show spanning tree active. I will not see 10, VLAN 10 being a part of spanning tree because I did not enable spanning tree on VLAN 10. To enable, I have to say configuration terminal spanning tree VLAN 10. Show spanning tree. It is not enabled. Okay, why is it not enabled? The reason is I need some connectivity. Okay, on switch number 5. On switch number 5, I created VLAN 10. Okay, I created VLAN 10. First of all, I created VLAN 10. I did not add this VLAN 10 to any interface. When I did not add VLAN to any interface, okay, because I did not add any interfaces or connect this VLAN to any interface, spanning tree is not running for VLAN 10. That is the reason. That is why when I did a show spanning tree active, you did not see that. Okay. And as I said, when I will be doing a practical for PVST protocol, I will show you all these different spanning tree active commands. For now, let's just go back to the original state. So you can see spanning tree is active for just one VLAN, VLAN number 1. Okay, what are the information it shows? It shows for this spanning tree instance, which is the root switch. Root switch is the switch which has this address. This is the root switch's address. This is the root switch's priority. And my cost, switch 5's cost to reach the root switch is 19. And it can reach via the interface 0/1. Okay, this is root switch's information. Then it shows its own information. What is my priority? What is my MAC address? And what are the hello time information? I will talk about this hello time later, not now. So there are two set of information that the switch shows. One is the root switch information. The other is its own information. This is the root switch priority. Root switch is MAC address. What is switch number 5's cost to reach the root switch, and through which interface can it reach? What is my MAC? What is my priority? What is my MAC? These are few information that switch number 5 is shown. And you can also see on switch number 5, because it is a non-root switch, it will have one root port. Because it is a non-root switch, it will have one root. So this clearly shows if you have a root port on a switch, it cannot be a root switch. अगर एक switch में root port दिखता है, वो switch root switch नहीं है. रूट स्विच में रूट पोर्ट्स नहीं होते, सिर्फ डेजिग्नेटेड पोर्ट्स होते हैं. तो अपना स्विच 6 है रूट स्विच. स्विच 6 की तरफ चलते हैं. On switch 6 you can see all the interfaces are designated port. That is why this switch is the root switch. Clear? So on non-root switches, no root ports are on non-root switches you will see one root port. Non-root switches, root port will be there. Root switches, no root port will be there. Clear? Show spanning tree active. On root switch, what did this say? It also says this is root switch's priority, this is root switch's MAC address. I am the root switch because I am the root switch, my cost to reach myself is 0. Here we saw on switch number 5, it showed the cost as 19. But here it says I am the root switch, that is cost is 0. This is my priority, my MAC address. So you will see on the root switch information and its own information are going to be same. MAC addresses are same. Ports, all ports are designated ports. And as I said, this is a fast Ethernet interface. The cost is 19. Cost is 19. Okay. Any question regarding the show spanning tree output?
ये लास्ट क्वेश्चन था, तो रिपीट
हाँ,
करना ही
पूछो.
पड़ेगा. बट ये जो रूट जो डेजिग्नेटेड पोर्ट थे ये अपने,
हाँ,
और जो
हाँ.
ब्लॉकिंग पोर्ट थे, ये दोनों सिलेक्शन, ब्लॉकिंग पोर्ट का सिलेक्शन कैसे हुआ था? हाँ ये
तो यहाँ पे ये डेजिग्नेटेड
हाँ
पोर्ट है, डेजिग्नेटेड पोर्ट.
हाँ हाँ.
यहाँ पे ब्लॉक पोर्ट कैसे सिलेक्ट होगा? पहला हायर कॉस्ट, दूसरा अगर कॉस्ट सेम हुआ तो हायर मैक. यहाँ पे ये है अपना रूट स्विच. स्विच 5 और स्विच 8 के बीच में ब्लॉक पोर्ट का इलेक्शन होगा. तो पहला देखा जाएगा दोनों में से कौन सा स्विच का कॉस्ट ज्यादा है. ये डायरेक्टली कनेक्टेड है, इसकी कॉस्ट 19 होगी. ये इनडायरेक्टली कनेक्टेड है, इसकी कॉस्ट 19 प्लस 19 कितनी होगी? 38. कॉस्ट किसकी ज्यादा है?
मतलब यहाँ पे एट एट का कैलकुलेशन होगा ना मतलब, जो कैलकुलेशन होगा 8 का होगा या 5 का होगा?
5 और 8 के बीच में है ना डीपीडीपी. तो इन दोनों में
अच्छा,
से
तो
कोई
5
एक ही
को,
अपना ब्लॉक पोर्ट क्रिएट करेगा.
तो मैं 5 को कंसीडर कर सकता हूँ इलेक्शन के लिए?
5 को ही कंसिडर करना है ना इसमें. इसमें
तो
5 ही
ठीक है.
कंसिडर हो रहा है.
हाँ, तो कॉस्टिंग के हिसाब से हो जाएगा. हायर कॉस्ट मतलब वो सेलेक्ट कर लेगा.
हाँ, जिसका हायर कॉस्ट है वो अपना इंटरफेस को ब्लॉक करेगा. तो ये इंटरफेस हो गया
दूसरा,
इसका ब्लॉक.
अगर कॉस्टिंग में अगर दोनों पे टाई टाई हो जाता है तो हायर मैक एड्रेस.
करेक्ट.
ठीक है.
हायर मैक. ठीक है.
ठीक है, बाकी में तो डाउट नहीं.
So the next topic that I have to take is uh, topology changes, indirect topology changes, direct topology changes, guards, BPDU guard, root guard, then rapid spanning tree protocol, per VLAN spanning tree protocol. Okay, so all that cannot be completed in one this particular session. So we'll continue that on the next weekend, that is next Saturday. Okay. So till here, what I have taught you today is spanning tree protocol, the theory about it, what is a loop, why a loop is created, and because of loop, how a broadcast storm is created, and because of broadcast storm, what are the problems that we meet. And to remove the looping, we have to block the unwanted interfaces. Right. So for that, we created spanning tree protocol. And on a spanning tree protocol, how a spanning tree creates a loop tree network, we just saw creating a root switch, root port, designated port, and a block. We also saw a scenario with multiple switches and how spanning tree would create a loop free environment. We also saw this through a simple diagram. Okay, this is what we have learned today. And in the next class, I will continue the next topic on next subtopic on spanning tree protocol. Before I end the call, any question?
नथिंग भाई, वो आप ये वीडियो शेयर कर देना थोड़ा, मतलब हम लोग रिकॉर्ड सेशन देखेंगे।
Yes, 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 no problem.
लाइक रिवीजन तो लगेगा, विदाउट रिवीजन तो नहीं हो पाएगी।
Yes, yes. ये मेरी एक रिक्वेस्ट है कि सिर्फ वीडियो पे डिपेंडेंट नहीं रहना है। ठीक है, आप अपनी खुद की भी स्टडी करनी पड़ेगी। ओके, वॉच माय रिकॉर्डिंग्स एंड create your own note, create your own notes. Okay, then only you will understand. Okay, so मैं ये बंद कर